Let's look at this function with algebra to see if this actually has a local max or local min on the closed interval from -1 to 2. When we talk about localizing around a number, we do not include the endpoints. So for x equals -1 or x equals 2, we don't talk about any local mins or local maxes there. At most, it could be absolute. But this question only asks for local. So that really means an investigation of the critical numbers. So why don't we begin by finding critical numbers? Now remember, there's type 1 and type 2 critical numbers, but they both involve the first derivative. And the first derivative here is a product rule. And it's best to take the greatest common factor and see what's left. We want our first derivative in reduced factored form. In this particular example, there is a numerator and a denominator. Let's indicate that. And we're ready to find type 1 and type 2 critical numbers. Type 1 is when the first derivative is equal to 0. And you end up solving this equation. So c equals 4/5 is a type 1 critical number. Type 2 occurs when the first derivative does not exist. So we're going to set the denominator of this first derivative equal to 0 and solve for the letter c. Cube both sides. Obviously, c equals 0 is a type 2 critical number. Now I'm going to label these critical numbers in order according to a number line, the x number line specifically, from left to right. Now I'm going to draw this number line. And we start drawing this at -1. I'm not too worried about scale. So I'm going to draw a hole here. And that hole is indicating the number 0. That hole is to remind me not to pick 0. We cannot ever test critical numbers. So here's another hole. This hole is going to be related to 4/5. It is the label of 4/5. We can never pick critical numbers into our first derivative. And then our endpoint is what? Our endpoint is actually a solid 2, so I'm going to fill in the 2 here. And we want to know how the function behaves in each of these subintervals. So it's your choice. You get to pick your own test value. I'm going to indicate triple star here. And when you pick your test value, I'm going to put it back into the triple star function. And we need to pick a test value between -1 and 0. I would just pick -1/2. And we want to know if this is positive or negative. You do a little bit of algebra. Notice the numerator is positive. The denominator, though, is negative. So what's positive over negative? Positive over negative is simply negative. Now that's the derivative. So make sure you put the function notation correctly. That tells us that the slope of the tangent line in that interval is always going to be negative. So f of x is actually decreasing on the interval from -1 to 0. Next, we're going to test the next open interval. We're going to look at this open interval, and we need to pick a test value. Let's pick f prime of 1/2. Let's do 1/3. Okay, you just got to pick a number between 0 and 4/5. It's your choice. You put that 1/3 over here and see if this first derivative is positive or negative. Now, notice the numerator is positive, the denominator will be positive, so positive over positive is positive. Now the function is going back up, and that is because the slope of the tangent lines to that function on that interval are all positive. One last interval to analyze using the first derivative. You need to pick a test value. I recommend that you pick something very convenient. What's a good number between 4/5 and 2? I would pick 1 here, and that is a little bit easier to evaluate. What is the first derivative evaluated at 1? Notice the numerator is going to be negative, the denominator is going to be positive, and so now we have negative over positive, and that is negative. What does that tell you about the function? The function's behavior on that open interval is now decreasing. Now, this is a good indicator of whether or not this has a local min or local max. So here we go. At C1 equals 0, there is a local max. I'm sorry, there is a local min. And it's just evaluated at 0 for your function. So what's f of 0? F of 0 is just 0. Ready for the other one. At the critical number 4/5, well, the function before 4/5 did what? It went up, and then after 4/5 it went down. So this has to be a local max. And it's actually evaluated at f of 4/5. And so whatever f of 4/5 is, you can do this off to the side if you need to. You could use some scratch work. F of 4/5, no problem. It's just 4/5 raised to the 2/3 power. And then, let's see here. 10/5 minus what? 4/5. So that's 6/5, right? And remember, the local max is a y value. Now, if you're curious, there is an equivalent form. If your algebra is so strong that it spikes your curiosity, there is an equivalent form for that number. But notice, using the analysis of the first derivative here will help you figure out whether a function has a local min or local max. And a number line drawing really helps.